48 is back to derivative world. So you have to change your train of thought. Okay, yesterday was integral antiderivative world. Today is back to derivatives. And today it is pretty much we're learning some trig derivatives. And I'm trying to think. Do we know what? Two basic trig derivatives? Derivative of sine is cosine. Derivative of cosine is negative sine. Do we know any others?
No, natural law. Derivative of a tangent will be negative cotangent.
No. Nope.
That shoots that way.
And in fact, we will, I believe, that's example 2 today. So, derivatives. Basically what's going to come down to is when we talk derivatives of various trig functions, you need to know the basics. So kind of like the basic core ones. Past that, when you get into some of the crazier ones, you don't necessarily have to have them memorized. What I'm actually going to show you today, though, is how if you forget a derivative, you could actually find it. And so that's what we're going to look at here. So example 1 asks us to use the fact that the derivative of sine with respect to x is cosine to find the derivative of cosine with respect to x. And so this right here is more an exercise in just trying to show something, to prove something. So let's start. We're trying to find the derivative of cosine, right? Even though, yes, I know, we already know it. But I want to show you a connection here. So y equals cosine x. Do you guys remember cofunctions? It's on that identity list. And the cofunctions are the ones that involve the pi over 2 minus x.
Equals like sine or something.
Well, so cosine of x is equal to, in cofunctions, it's equal to sine of pi over 2 minus x. Okay. So those are cofunctions. You have them back somewhere towards the front of your notes, right? You had a whole big list. It's probably within the first 10 lessons, I would guess. But those are cofunctions. So right there, I'm trying to find the derivative of cosine. And the idea here is if we don't know the derivative of cosine, but we do know the derivative of sine. So y equals cosine x is the same as saying y equals sine of pi over 2 minus x. So let's take the derivative of this, because up here, you already know it, but we know the derivative of sine is cosine. So derivative of y, I'm going with respect to x, so I'm saying dy dx. Derivative of sine of something is cosine of something. And what do you have to remember when I say that something? So derivative of sine of something is cosine of something times the derivative of something. Remember your chain rule there? Maybe?
You're kind of losing it. Can you write it out? Yeah.
Okay.
My words.
Okay. So derivative of sine of pi over 2 minus x is cosine of pi over 2 minus x. But then remember, you have to do the chain rule. So derivative of the outside times derivative of the inside. So derivative of sine of something is cosine of something times what's the derivative of pi over 2 minus x? Well, pi over 2 is just a number, right? So derivative of a number goes to 0. What's the derivative of negative x? Negative 1. So this is times, excuse me, a negative 1. Now, if I rewrite that, so I'm just going to reorder it, put the negative out front, dy dx equals negative of cosine of pi over 2 minus x. What do cofunctions tell me now? Cosine of pi over 2 minus x is equal to sine of x. Sorry, I forgot my variable for a moment. The negative out front will just carry down. So dy dx is equal to the negative cosine of pi over 2 minus x, which is sine of x. So again, that is a cofunction connection.
Why do we have to do it like all of this?
It's more of, and I'll be honest, in this case, it is kind of crazy. But it's more of, I know. It's more of an idea of we're proving what it is. Okay, using the connections. It'll make a little bit more sense, and this is the only one I think that we use cofunctions on, so that'll be a little bit better. But it's more the idea of if you forget a derivative and you know some of the basics, like if you know derivative of sine is cosine, you can use that to find other derivatives. And that's the idea of what I'm going to be showing you today. Okay. Now, what was the whole point of this? We're using that fact to find the derivative of cosine with respect to x. Did I find that? We started with cosine. What's the derivative? The derivative of cosine is negative sine. So I'm going to be writing out the various ones we find today. So a way to write this and say the derivative of cosine is negative sine is to say d dx of cosine x, that's saying the derivative of cosine x is equal to negative sine x. So that one we were trying to find the derivative of cosine. As I said, that's the only one that uses the cofunctions, and I think that makes it a little bit more confusing, honestly. But I think these others, you'll follow a little bit better. So give me a chance is what I'm saying here, okay? We're ready for number 2? Okay, so this is one we don't know the derivative of. Use the quotient rule and the derivatives of sine and cosine to find the derivative of tangent x. And we learned the derivative of tangent x. No. And after today, it just needs to go into that memory bank. It needs to be memorized. It's not one you're going to want to have to work out every time.
The bank's closed.
Nope, can't be closed. So we're going to start. Y equals tangent x. Now, I can't just find the derivative of tangent because I don't know it. But it gave me a hint, and it said to use the derivatives of sine and cosine. So what do we know about tangent? Okay, so I'm going to rewrite this in that tangent x is equivalent to sine x over cosine x. I haven't changed the statement, I've just written an equivalent statement. Agree? Now, we're going to take the derivative because we know derivatives of sine and cosine, right? Now keep in mind, this is a fraction. So they already gave us a hint, but what are we going to have to use? Quotient rule. This is not just derivative on top, derivative on bottom. So we're going to review that quotient rule. So, derivative of y, there's my dy dx. How's that quotient rule work?
The derivative of the top times the bottom plus the derivative of the bottom times the top over the bottom.
Okay, one tiny mistake, otherwise he's got it perfect. That top sign in the middle is a minus. When it's the product rule, it's adding. When it's the quotient rule, it's subtract. Okay, so derivative of the top. What's the derivative of sine x? Cosine x. Times the denominator, as is. So times another cosine x. Minus. Now we reverse it. Derivative of the denominator. What is the derivative of cosine x? Negative sine x. Times the numerator, as is. All over, denominator squared. So cosine squared x. Okay, clean up. Cosine x times cosine x is cosine squared x minus negative sine x times sine x. It ends up being plus sine squared x all over the denominator of cosine squared x. What do you know about that numerator? What? 1. Pythagorean identity. Sine squared plus cosine squared equals 1. So, you need me to... Nope. Nope. Sine squared plus cosine squared is equal to 1. That's usually how that one's given. It's the other two that are, they have the plus 1 on one side that you have to move them around more. But in this case, it's just as is. So now, wrong pen, dy dx is equal to 1 over cosine squared. What is a different way, or what's equivalent to 1 over cosine squared? What trig function can we write that as? The reciprocal of cosine is secant. So 1 over cosine squared is equivalent to secant squared. So what did we just find? The derivative of tangent x is secant squared x. As I said, it's just one to commit to the memory. So I'm going to write it over here. Dx, so derivative of tangent x, is equal to secant squared x.
This doesn't seem too bad.
And okay, and here's the deal. If you're asked in a random problem derivative of tangent, do you have to do all this work? No. Can you do this work if you get stuck on the AP test and you don't know it? And you can't remember it? Yeah, this is a way to find the derivative of tangent if you don't remember it. Honestly, by that point, you're going to know it. Okay?
I feel like this problem was already health challenge.
Huh?
Was this problem already was health challenge?
I don't remember.
It looks very.
I don't even work, and I was like, no way.
Okay, so side comment, because the girls already discovered it, or two of the girls did. We only have the front page of notes to do. Have you guys checked to see what the back page of the notes is?
Oh, never mind. It asked for cotangent x.
Okay. So, on the back side is a summary of rules for derivatives and differentials. Okay. So, for instance, if you go down far enough, you'll find the derivative of tangent x is secant squared x. Okay. So, this is essentially going to be, I mean, a lot of those you already know. You already know the derivative of a constant is 0. A constant times a variable, so like 5x is just 5. You know a lot of these. The product rule, quotient rule are there, your power rule, derivative of e of x, ln x, derivative of sine and cosine. It's the bottom 4 that you're going to be adding to memory. Okay? And that's what we're proving today. I'm just showing you ways that if you do forget them, you can technically find them. Okay? And it's a good skill to have. How often do you use it? Not very, but again, it's a skill. So, moving along, even though you know the next 3 answers now, we still need to work them out. You can just be impressed that they work out to be the answer on the back side, right? And we're still practicing, like in that last one, we practiced our quotient rule. Do we need practice on quotient rule? Definitely. Okay, example 3. Use the quotient rule again and the derivatives of sine and cosine to find the derivative of cotangent x. Can you see the direction this one's going? So I'm going to start with y equals cotangent x. So what do we know about cotangent? Okay. So equivalent statement is that y is cosine x over sine x. We ready to take the derivative? So derivative of y with respect to x, dy dx. This is a fraction. So again, we are using the quotient rule. Derivative of cosine. Sorry, derivative of the time. So derivative of cosine is negative sine x times the denominator, which is already sine x. And then what? Minus. Now it's derivative of the denominator. So derivative of sine x, cosine x, times the numerator as is, which is cosine x, all over denominator squared, sine squared x.
My OCD is not digging me underestimating how long that fraction is going to be. Like having to extend it and then
Okay, clean up the top. Negative sine x times sine x is going to be negative sine squared x minus cosine x times cosine x. So minus cosine squared x all over sine squared x. See where the next step needs to go? Yep, factor out negative 1. So if we factor out negative 1 on top, it's the negative, and then in the parentheses it becomes, yep, sine squared x plus cosine squared x. I'm not going to be picky. I knew what you meant. And so what do you know about the negative of sine squared x plus cosine squared x? It's going to be negative 1 on top. So dy dx is negative 1 over sine squared x. And what is the reciprocal of sine squared x? Reciprocal of sine is cosecant.
Oh, yeah.
You said sine and I was like, sine.
No, reciprocal of sine is cosecant. There's a negative there, so this is negative cosecant squared x. Cosine and sine are not reciprocals. We do think of them together a lot. So, what did we just learn here? The derivative of cotangent x is negative cosecant squared x. And if you don't believe me, check the list on the back, right? Okay. The nice thing is, well, this will make more sense once we get through the next two. If you can remember the derivative of tangent is secant squared x, you just kind of have to remember that the derivative of cotangent then is the other one with a negative sign thrown on. Okay?
So if we have this problem on homework or on the test, are you wanting us to work through it like this, or do you want us to just memorize the thing and write it down?
You only have to work through it if it says prove, show, something along those lines. Okay? Honestly, you're not going to have just what's the derivative of tangent. Or what's it, it's going to be thrown into something, would be my guess. But does that answer the question? Yeah, unless it says show or prove. No, I'm not going to expect you to work through. Okay, what's the next one I'm doing? Use the quotient rule and the fact that secant is the reciprocal of cosine to find the derivative of secant x. So I am starting with y equals secant x. And what hint did it give me in there? The fact, okay, secant is the reciprocal of cosine. So secant can be rewritten as how? 1 over cosine x. And I know the derivative of cosine, yes? So I'll be able to do this. Now what's the trick here? This is a fraction, so we have to use our quotient rule. You know you want lots of practice on the quotient rule today. Okay, dy dx, derivative of the top, so what's the derivative of 1? 0. Times the denominator, so 0 times cosine x, minus derivative of cosine x. So derivative of cosine is negative sine x times the numerator as is, all over cosine squared x.
Wait, so the denominator is just the denominator squared?
Yes. Okay. Clean up. What do we have on top now? Sine x. So dy dx, whoops, equals sine x over cosine squared x. And if you remember the backside, this is not our final answer. And so the easiest way I can make is I want to split this up into 2 fractions.
Here we go.
Oh, she just snitched.
So I guess we can talk 6 hours. What I want to know is why are they out of class early?
Is that Mr. Summers' class this time, or is that Stanley's?
Are they English Mr.
I think it's Holman.
Oh, I forgot how this down.
Speech.
Yeah. That's my question is why are they out of class early? You don't deserve to be out of class early if that's how you're going to behave. Okay. Split this up into 2 fractions is what I was saying. Cosine squared x can be split into cosine x times cosine x. The denominator, that's the denominator. The numerator, we just have a sine x. Yep. So I'm going to say, I'm going to put sine x on the first and 1 on the second, just because that's how my brain remembers it. Officially, it doesn't matter now. Okay. So now, convert each of those fractions. What is sine over cosine? Tangent. What is 1 over cosine? Secant. And so what we just learned is the derivative of secant is secant tangent. Now, that's why I put tangent and then secant. I just said it backwards. I said it right. Because my brain says the derivative of secant is tangent secant, that's the order my brain remembers it in. And that's where you'll usually see it. Not that you couldn't say the derivative is secant tangent. It's just a matter of how you do it. So, lesson learned out of this one. d dx, so the derivative of secant x is equal to tangent x, secant x. That's another good one to know, because if you know the derivative of secant, you can kind of figure out the derivative of cosecant, which is next up on the list. I would ask you if you could guess what it's going to be based on our progression, but you guys have already seen the backside, so it's not as much of a guess as it was. But here's the connection I see, guys. The derivative of tangent was secant squared, yes? The derivative of cotangent is the other one. It's cosecant squared, and it had to be a negative. So when we get down here, the derivative of secant is tangent secant. So now we're doing the derivative of cosecant. Derivative of cosecant is going to have a cotangent and a cosecant in it, and it's going to have to be negative. So I can kind of see a progression there. I don't know if you guys maybe know. Cassie said no. Blade's kind of saying yeah. I don't know. So somehow you've got to figure out a way to remember them though. Okay. So we are starting y equals cosecant x. It said to use the fact that we know the reciprocal of cosecant. What's the reciprocal of cosecant? Reciprocal of cosecant is sine. So this is 1 over sine x. We're ready to do our derivative? Okay. Quotient rule one last time. Derivative of the numerator. 0 times the denominator, sine x. Quotient rule says minus. Derivative of the denominator. So derivative of sine is cosine x times the numerator of 1, as is, all over the denominator squared. Sine squared x. Clean it up. What do I have on top? Negative cosine x over sine squared x. Yep, split it into two fractions. So I have sine x in both the denominators. One numerator is the cosine x, the other numerator is 1, and out front somewhere you should have a negative. So, negative, what is cosine over sine? Cotangent. And what is 1 over sine? Cosecant. So, we have just proved that the derivative of cosecant x is negative cotangent x, cosecant x. Again, the backside, again, it's just derivatives, okay? As of now, you officially know all those derivatives on the backside. Let me rephrase that. As of now, you should know all those derivatives on the backside, okay? And some of those ones up top that look confusing, all this top one says is the derivative of a constant, so derivative of a number is 0. Derivative of a number times a variable is just the number. It's like derivative of 5x is 5. Derivative of two things being added, you just take each derivative. Here's the product rule. So that's derivative of the first, keep the second, plus keep the first, derivative of the second. Here's the quotient rule we did so many times. Our power rule, where you bring the number out front, subtract 1 from the power. Derivative of e to the x, you guys already know. E to the x, derivative of natural log of x, 1 over x. And then the 6 trig ones that you should know. Okay? Again, for the most part, though, sine and cosine will get you through most things. Okay?